Welcome everybody to lesson number 4. Today I'm going to talk about the relative wage. As I've already shown in lesson number 3, the high wage equals to this expression and the low wage equals to this expression. It's derived from the profit function of a firm. So to get the relative wage we have to divide the high wage by the low wage. If we do this, we get that a to the power of p times the price times h to the power of p minus 1 times the bracket to the power of 1 minus p divided by p divided by a to the power of p times the price times L to the power of p minus 1 times the bracket to the power of 1 minus p divided by p. So what we can see here is that actually this bracket and this bracket are the same, so they cancel out. And also here's the price and there's the price, so also though they cancel out. So what we can also notice that it doesn't matter if we assume if the price of the output is equal to 1 or not for the relative wage, because it cancels out anyway. So we get that a to the power of p divided by a L to the power of p times h to the power of p minus 1 divided by L to the power of p minus 1 is equal to the relative wage. So what we have to do now is to convert this exponent again from the form with the p into the form with the sigma. So that's what I'm gonna do now. What we can do first is we can take the inverse. So 1 divided by sigma equals to 1 minus p, and if we now multiply everything by minus 1, we get that minus 1 divided by sigma equals to p minus 1. So p minus 1 equals to minus 1 divided by sigma. We have p minus 1 here. So what we can already do is we can say that a L both have the same exponent, so I can also write it outside the bracket. What p is I'm gonna show in a second, but what we already see is that h divided by L to the power of p minus 1 can also be written as to the power of minus 1 divided by sigma. So we still have a p here that we have to convert into the sigma form. So that's one step left actually. It's just this one to the other side. So p equals to 1 minus 1 divided by sigma. And again, what I can do is say that 1 divided by 1 minus sigma. Can also rewrite this 1 as a sigma divided by sigma, so that p equals to sigma divided by 1, sigma minus 1 divided by sigma. So yeah, that's a sigma. So actually this p turns into a sigma minus 1 divided by sigma. Sigma minus 1 divided by sigma. So this is actually how the relative wage looks like. Yeah, that's interesting, but what we can actually do and what we can derive from it, we can take the logarithm, and yeah, what we can derive from it I'm gonna tell you later. So if we take the logarithm of this expression, we have the logarithm of the relative wage, that is equal to the logarithm of the exponent, then it's just the exponent, so sigma minus 1 divided by sigma times the logarithm of a h divided by a l, and here if you take the logarithm here, the exponent comes down, so it's minus 1 divided by sigma times the logarithm of h divided by l. So this expression actually tells us something very interesting, because imagine we would have our labor demand and labor supply model. So there's the axis, and here's another one, and we would measure now here the logarithm of h divided by l, and here the logarithm of the relative wage. We can actually see now that this expression shows us the slope of the demand curve. This is the demand curve. As we normally know, this is downward sloping. So to get to this demand curve, we would actually derive this expression with respect to the logarithm of h divided by l to get to its slope. So what would be left over is this minus 1 divided by sigma. So the slope of this would be minus 1 divided by sigma. And yeah, what this sigma actually is, this sigma is the elasticity of substitution between the low-skilled and high-skilled workers. So actually, we can see due to this expression how the elasticity of substitution affects the labor demand curve if we plot it in the way that we have here the logarithm of the relative employment and here the logarithm of the relative wage.